and welcome, and in this video we're going to continue solving three variable systems. Okay, so I'm going to cover two more examples here. If you haven't watched the previous video on solving three variable systems, make sure you do that. I'll put a link in the description below. Okay, because I'm not going to explain every single little tiny step in this video as I did in the previous one. All right, so let's go straight into solving this problem. So we have a three variable system here. Okay, I'll let you read it for yourself. And remember, when I solve three variable systems, I generally like to use elimination. Okay, so when I'm using elimination, I'm thinking about what variable looks the easiest to cancel out. Now, you can make a case for A and B. Both of those variables are the ones that stick out to me because with A, I have -6, -2, and 4 as coefficients, and they have a lot of common multiples. I'd be able to just basically multiply this second equation by either 2 or 3 to get to cancel out the A's. But I'm actually going to focus on the B's. And the reason I'm focusing on the B's is because if I just add these this first and third equation together, the B's end up actually canceling out. So that creates a little bit less work for me. And I'm a little lazy, so I'm going to try to do as little work as possible. So I'm going to go ahead and rewrite the first and third equation and add them together to get a new equation. Let me go ahead and do that now. Okay, so I went ahead and I added the first and third equation together because that eliminated the B's, okay, and that left me with -2a plus 7c is equal to -15. So now I have a new equation, okay, but I still need another equation, and I need to cancel out the B's once again to get that new equation. Now I used the first and third equations, okay, so I can't use that combination again. So I'm gonna go ahead and you can either use the first and second or the second and third. I'm gonna go ahead and use the second and third because I'm gonna multiply this second equation through by 5. I'm gonna multiply the second equation through by 5 because when I do that, when I multiply the second equation through by 5, that's gonna become 5b. So when I add 5b and -5b, they will once again cancel out. So I'm going to go ahead and do that now. Okay, so I went ahead and did that. So now when I multiplied the second equation through by 5 and I added it to the third equation, I'm left with -6a plus 25c is equal to -49. So now I have these two new equations here, and this creates kind of a new system. So if we went ahead and wrote them on top of one another, -2a plus 7c is equal to -15, and -6a plus 25c is equal to -49. I now have a new two variable system that I could use. Now you could use either substitution or elimination from this point. I'm going to go ahead and actually use elimination once again because it would be a little challenging to use substitution. I'd be left with fractions, which I'm going to try to avoid if I can. And also because if I'm looking at the variables or the coefficients on A, I have -2 and -6. If I multiplied this top equation here by -3 or +3, you can use whichever one. But if I multiplied it by -3, this would become a +6a. So when I add the two equations together, they would end up, the a's would end up canceling. So I'm going to go ahead and do that now. Okay, and that led us to being able to solve for our first variable, okay? So I multiplied that equation here by -3, and when I added them together, the a's ended up canceling out, leaving me with just the c variable, okay? And that left me with 4c is equal to -4, which means c is equal to -1, okay? And remember, once you have your first variable solved for, now all we have to do is work backwards. So what I can do is I can now substitute in c as -1 into either of these two equations here. So I'm going to go ahead and I'm going to take what c is -1, and I'm going to substitute it in for c into this equation up here, because once I do that, I'm going to be able to solve for a. All right, so let's go ahead and do that. All right, so I went ahead and did that. So I substituted in -1 for c, so I did that right down here. So that left me with -2a plus 7 times c, which is -1, is equal to -15. And then I was able to solve for a, and that got me a is equal to 4. And now what I can do is I have a, I have c. I can now substitute those values into any one of the three original equations here and solve for the remaining variable of b. okay? So it doesn't matter which of these three equations, but I'm definitely going to be using the second one because b doesn't have a coefficient on it, which makes it a little bit easier to solve. So I'm going to go ahead and substitute in a is 4 and c is -1 into the second equation. Just know you could use the first and third. It really does not matter. Okay, and I substituted that into that second equation here, which left me getting b minus 12 is equal to -9, and that gets me b is 3. So I now have a, I have b, I have c, but remember the solution to a 3-variable system is actually where 3 planes are intersecting, so I need to write this as an ordered triple. So that ordered triple and the solution would end up being a, b, c, so 4, 3, -1, and that would end up being our solution. All right, so that was one example. Let's take a look at one more just to get our feet a little bit more wet. Okay, so let's go ahead and take a look at another example. Okay, so we have a new example here. I'll let you guys read it for yourself. But once again, I'm going to use elimination here. And as I'm looking, the easiest variable, in my opinion, to eliminate is going to be z. Because if I'm looking here, I have -3z or -3z. So if I were to subtract those two equations, the z's would end up canceling. Or I can multiply one of those equations by -1 and then just add them, basically the equivalent of subtracting. And once again, the z's would end up canceling. So that's actually what I'm going to do. I'm going to be focusing on canceling out the z's. So I'm going to first use the first and third equation. Now you could subtract them. I'm going to multiply one of them by -1 just because I rather add it. It's just a little bit easier for me personally to do. So I'm going to go ahead and do that. All right, so that was the first set of equations we used and canceled out the z. So either if you subtracted the first and third equation or if you multiplied one of these equations, you would end up with something like this. So I multiplied the first equation through by -1 and then added the first and third, and that left me with x minus y is equal to 0, okay? So now I can't use a combination of the first and third equations. So I'm going to go ahead and use these second and third equations. Now, when I'm doing this is -2z, we have -3z. The least common multiple between 2 and 3 is 6. So I'm going to want to change one of these into a positive 6z and the other one into a -6z. So to do that, what I am going to do is I can multiply the second equation through by -3, making this a positive 6z, and then I can multiply this third equation by just a regular positive 2 to make that -6z. So when I add them together, the z's are going to end up canceling out. So that's what I'll go ahead and do. Give me 1 second. Okay, so I went ahead and did that, and that left me with -7x plus 16y is equal to 36, okay? Now, I do have two new equations, so let me go ahead and write them on top of each other. I have x minus y is equal to 0. Let me write that 0 a little bit nicer, 0. And I also have -7x plus 16y is equal to 36, okay? Now, I can use elimination, I can use substitution from here. I'm actually going to go ahead and use substitution because if I just add y to the other side, I get x is equal to y. And that's actually really kind of neat. Now I know x and y are going to be the exact same number, which is going to make things a little bit easier from here on out. And now I can go ahead and substitute either y in for x or x in for y into my second equation down here. Okay, so I'm going to go ahead and I'm going to take y and substitute it in for x. So now when I go ahead and do that, I'm going to end up with -7 times x, which I found is y, plus 16y is equal to 36, okay? So now that's telling me -7y plus 16y is equal to 36, and now everything is in terms of y, so I can solve for y. So this is going to end up becoming 9y is equal to 36, which tells me y is equal to 4, okay? So now I have y is equal to 4, and I can substitute that in for y up here, which tells me that x is also equal to 4, okay? Remember, x and y are equal, so that tells me that x and y are both equal to 4. And what's really nice about that is now I can kind of go straight to finding my last variable of z by plugging in x and y into any of the original 3 equations, okay? So I'm going to go ahead and I'll plug them into the first equation, and let's solve for z by doing that. Okay, so we went ahead and we substituted in 4 for x and also 4 for y because they were equal into x and y into that first equation. And then we simplified to get z is equal to 1. So now I have my final answer. But remember, we got to write it as an ordered triple. So we have x, which is 4, y, which is 4, and z, which is 1. And that would end up being our final answer, okay? I hope this was helpful. If you have any questions, please feel free to let me know. In the next couple of videos, we are going to be talking about the applications of 3 variable systems, okay? So I look forward to seeing you guys in the next video.